Perfect. The recording has started. Thank you for joining me this morning. So, today we are talking about Spark Session 2. You understood what is Spark, Spark platform, what is an RDD, what is an REPL. REPL is nothing but read, evaluate, print loop, and how Spark works in real time. And we also understood the enterprise Spark applications. So now, continuing from there, I also explained you what is Spark with Scala, Spark with Python, how Spark shell invokes Scala, and PySpark invokes Spark with Python. Okay, this till this point you are clear. If you have questions, you can ask me now. Enterprise level Spark also explained you very clearly what is an executor, what is a driver, and what is Spark context, and how your Spark local and how your Spark local mode and how your Spark yarn mode works differently. Now we need to understand how drivers makes really a solidly Spark programming a great thing. Okay. Now, the Spark driver contains the main Spark program that manages the overall execution of Spark application. Okay, let's break this sentence into a small one. See, for anything, if you remember in Java, it starts with main class and then you will see void some other case classes. Correct? Like that, your Spark driver contains a main Spark program, and this is the one that is responsible for the overall execution of Spark application. Okay, this main program or this main with the brackets is nothing but a Java virtual machine that is creating a Spark context which then communicates with the Spark directly. Here you need to understand one thing. You know what is a service, you know what is a client. Okay, now this driver is a kind of client that is interacting with your Spark. However, the main Spark driver, that is like a JVM, is loading the Spark context which is communicating with the Spark. Now, it's not just communicating, this is also responsible for writing, displaying, and storing the logs. Okay, that Spark context gathers from the executors. Let's revise, guys. Very simple. Spark driver is nothing but it is a kind of client that is interacting with your Spark main. Now, the Spark main is the driver that is having the overall execution of Spark application. It is a Java virtual machine. Simple. Understand the theory first and then I'll show you the practical part of it. Okay. Now, this Spark main driver is responsible for displaying and storing the logs that Spark context gathers from executors. Now you understood what is a driver. You understood what is executor. Driver's responsibility is to take your Spark code to the Spark framework, and then there it will make it to execute by executors. So like the way we understood Spark driver, we also understand how executors works. Now the Spark shell REPLs are example of Spark driver programs. Okay, this is my one example for the this is one example of my Spark REPL. Okay, now the Spark driver is a single point of failure for Yarn client application. If the driver fails, the application will fail. This is mitigated when deploying application Yarn cluster. That is what I've shown you here yesterday. Let me exit from here. It's gone. That's okay, no problem. Perfect. Spark shell master local. if somebody is active on Spark, it will fail. Yeah, see here. If you see here, Spark context master local, it just opened Spark, okay? And here it also told, boss, I'm using Scala version 2.10.5. Okay, Spark context is available as SC, S for Spark, C for context. SQL context is available as SQL context. Now, if you remember our old slide, which explains very clearly that Spark is a streaming application. Spark works on machine learning. Spark works on SQL and other bits. That is nothing but this one. Let me show you that. See here, it works with, let me show once again, just to make sure you understand things right. Scala, Java, and Python API, machine learning API, machine learning libraries, Spark SQL, Spark streaming, and graphics. Okay, that's what it is. So now we understood, when you launch Spark, you will see this bit. Okay, now this is local mode. This is not integrating with Spark. Okay, now, sorry, yes, erase all drawings, pointer. Okay, now let me exit from here and let me go to yarn mode. Look at the difference what happens if I log into yarn mode. Spark shell. See, this has initiated Spark in cluster mode. Okay, in the command point of view and the result point of view, you won't see much difference. But in Spark shell, your application will be submitted to yarn directly, and in Spark shell master local, it will be submitted to the node manager of your Spark running on that specific node. Okay, that's what it is. Now you're on gateway node. The Spark will communicate with the local Spark executor, not to the yarn cluster. That's what all my trials were. Okay, to show you. This is clear now. You understand Spark driver as well. Guys, first understand theory nicely, and then we can jump into doing practicals one by one. Okay, this is Spark driver and Spark uh, conf, Spark main conf. Okay, this is very important. The Spark driver contains a main Spark program that manages the overall execution. Okay, now the Spark driver is single point of application for the yarn application. Spark driver is single point of failure. Okay, if the driver fails, the application will also fail. If you have deployed Spark, if you deployed Spark in yarn cluster, you can mitigate this. Okay, now why is Spark context a very important? Okay, guys, understand this is very important. You need to really understand the difference with Spark conf. Okay, for any application to become a Spark application, okay, an instance of Spark context class must be instantiated. For example, all these things came from Java. Okay, anything you do on Java or object oriented programming must be first instantiated. Means you must first create a variable and you assign a value to that variable. Like that, you first create a context of Spark telling, dear Spark, I'm going to use you. Okay, for example, if you launch here, you said Spark context is available as SC. This is one example. SQL context is available as SQL context. Means this Spark API is now helping you to use Spark in two ways. That is Spark with Scala context and Spark with SQL context. Like that, here for any application to become a Spark application, an instance of Spark context must be instantiated. So in our lab, when you instantiated Spark, it came up telling, I can help you on Spark with Scala context. I can also help you with Spark in SQL context, which is much appreciated. I'm happy with that. Now, the Spark context will also, the Spark context contains all the code and objects required to process the data in the cluster and works with Yarn Resource Manager to get the requested resources for application. I agree. That is what I was trying to tell you. When you have initiated Spark with cluster mode, with Yarn mode, the Spark context is the one that is having the actual code and the objects that are required for the execution. Now, when you need to process the data, you need resources. This Spark context will directly talk to Yarn Resource Manager to get all those resources, which is what the whole concept is. Very good. Now, it is also responsible for scheduling tasks for Spark executors. Now let's come back to Spark drivers and executors. Spark driver is nothing but one of the REPL. Your REPL is one Spark executor. My REPL is one Spark executor. Ram Prasad REPL is one Spark executor, and Shravan's is one other executor. Like this, there may be many number of executors submitting the task to Yarn Resource Manager, which is Yarn cluster. Okay, like that, like that. Now, all your executors scheduling will be taken care by Spark context. Okay, the Spark context also checks with executors to report work being done and provide log updates. To be more clear, the way your Yarn Resource Manager working with Node Manager, your Spark context is the one that is working with your Yarn, because first thing, it has a code, it has to process the data. To do the work, it needs resources. Yarn will give the resources. Step number 1 done. Step number 2, you have many number of REPLs, drivers. Your drivers must talk to executors. Your executors taking the resource from Yarn must report, boss, I have done my work. Now I have finished my work. Now this is what I'm doing. It is also providing the log updates. That is what it is about. Spark context. Now, it may be little boring, guys. I understand it may be boring, but we have to first initially understand the concept very clearly. If you don't understand this bit, and if you start learning Spark, if your foundation is not strong, we'll mess up later. Okay. Now, a Spark context is automatically created and named SC when REPL is launched. This is very, very important. That is what I've shown you. So you need not have to create any exclusive Spark context. If you launch REPL, which is this one, which is your executor, which is your shell, you will see it's automatically loaded. Spark context is available as SC. This bit is nothing but, see, I highlighted something here. This bit is nothing but this one. Okay, this one. Now, the following code is executed as a startup for PySpark. Okay, for example, if you see here, I'll execute it. I'll exit from here. I'll go to PySpark. Okay, let me show you. Python 2.5.7 is loaded. Okay, now guys, focus. Spark context is available as SC. Hive context is available as SQL context. Now see here, I'm just copying and pasting it. Observe, guys, I'm telling from PySpark import Spark context. Having said, I need not have to do it, but I'm showing you what happens if I do it. Okay, from PySpark import Spark context. Why? Why? The Spark context is so important that for every application to be Spark application, the Spark context must be instantiated. Spark context is the one that has the actual code and it helps you in data processing and resources necessary. Okay, invalid syntax. Okay, now if I do this one, the test taken. Now after that I'll do this bit spark config spark. I can just use this one, not that. Conf equal to spark conf, instantiating spark conf. Okay, sorry, wait. Spark conf is not defined. This is just doing an extra work on top of it. I'm just trying to show you that. Okay, I understood. I understood. Why to conf here? Spark conf is not defined. One minute, guys. Let me check this. Is this syntax error or something? There is syntax error. I'm just trying to correct it. Bear with me. Yeah. See, this is what we have done here. From PySpark import Spark context. Okay, this is correct till here. Okay, I'll do that once again. Compare it carefully. From PySpark import Spark context, comma Spark conf, comma Spark conf. This is perfect. After that, conf equal to Spark conf. That is what the problem is. This one should come in new line. Sorry guys, 1 minute. Control Z. This bit must come in new line. Okay. Now it will work. Definitely. A small mistake in the syntax, and I don't need 2 lines here. 1 line is enough. Okay. Now there is space here. Don't forget the space. Okay. Now let me load this one and see if that takes. Just explain you practically what happens if I load it. Any questions, please feel free to ask me. Now it has taken up. See guys, it has not a real message. If I go to my PPT again and load second bit, which is conf equal to spark conf, see what happens. It has taken perfectly. I appreciate it. Now sc equal to spark context conf of conf. Okay. You may be really confusing. This may be confusing to you, but still I'll explain that right now. Don't worry. See, if you see here, cannot run multiple Spark context at once. Existing Spark context is this one, created by user HTTP Spark Python, because guys, try to understand something. It already said Spark context is available as SC. Hive context is available as SQL context. Okay, in here Spark is already embedded with Yarn, but if you install Spark on your local Mac or Windows, you have to do this every time, this bit. Okay, the reason why we are getting this error message is it cannot run multiple Spark contexts at once. As our Spark is integrated with Yarn, whenever you launch Spark, you will see SC, Spark context instantiated. I told you also, while I am creating the Spark context manually, I said I need not have to do it, but I wanted to show you what happens. So This parconf, to show you more practically, uses a Java case class in the background. See here. Okay, let me read this for you. Configuration of for a Spark application used to set various Spark parameters are key value pairs. I appreciate it. I got that. Most of the time, you would create a Spark conf object with Spark conf, which will load the values from Spark star.java system properties as well. In this case, any parameters you set directly on SparkConf object will take priority over system properties. That's all it is. At the moment, I don't want you to break your head. I want you to understand only one point. SparkConf or Spark context can be imported manually, or if your Spark is integrated with Yarn, you need not have to worry about it at all. Even though, even after your Spark context is installed, is Spark context configured with Yarn, if you overwrite it, it will say, "Boss, I'm sorry, I cannot do all the things at a time, or I can do multiple instances. I cannot run it at a time." That's what it is. Okay. So hope you understood the concept. If you have any questions, stop me. This PySpark import Spark context. If you want me to break this code, I can break it. Okay. If you simply copy this one, it will show you what it is doing. This is how your developer thinks. And if you want to check it in the form of Maven in Eclipse, let's take Sprint Context 4.2.0 release. Okay. And if you check here, one minute guys, I'm trying to find it out. Bear with me. I want to show you the exact code what is running behind this one. JDK projects method. Yeah, we want to check methods. So search for this method. I want to break the whole code of this one. This single line in the background for Java is other 6 or 7 lines. I'm trying to show that.
Maybe that will be a bit scary to see, Amar.
No, don't worry. We are not bothered about it, but we need to understand how this has come in front of you when Java was there. Yeah, check in all repositories. And I think I'm missing it somewhere. Let me check if I have it here. I think it is taking some time. I'll sort it out later. That's just optional, guys. I just want to show you to make you feel comfortable that how exactly it runs in the background with one line. For you, it's a one line, but it is decoded into the Java configurations in the background. I try to show that, but I need to do some filtrations in grep code. I'll do that later. Okay. Now let me quickly come back. Till this point, are you clear? Did you understand what Spark context is? Everyone.
Yeah, it's all right, Amar.
Perfect. Now let's go to Spark executors. Okay. Now, simple guys, take this diagram, have a look. You are done with the Spark executors. Okay. Very simple. Very easy also. Let me see here. Take the pen. This is your cluster. This is your name node. Worker 1, worker 2, worker 3, worker 4. Having said earlier, you have a yarn resource manager on your name node. You have a yarn node manager on your data nodes. Your yarn node manager will have a executor. Okay, this is that executor. Okay, now for some you may have two executors, for some you may have two executors, for some you may have one executor. That doesn't matter. Okay, now these executors are the actual job runners for your Spark application. Okay, now you need to understand how they can work together. Let me show you that. Let me go to pointer. Let me get this down like this. Okay, now see, the Spark executor is the important component that does perform the MapReduce task of Spark application. Let me tell you once again, Spark is a non-MapReduce application, but the way Hadoop understands everything is in the form of a MapReduce. That is the reason why I'm comparing it here with MapReduce. The Spark executor is a component that does perform everything as a Spark executor. Okay, like a MapReduce job. Now, this one is sometimes referred as Spark worker. Once created, executor exists the life of application. That's cool. Now, Spark executors functions as a interchangeable workspaces for Spark application processing. Now, this is, let's break this one. If an executor lost while an application is running, all tasks assigned to it will be reassigned to some other executor. That is what it is. That is what the resilience is. We are talking about resilient distribution data set. So if an executor of one Spark is failed, all the associated tasks for that executor will also be failed, but the Spark will reassign that to a new executor. Okay, in addition, any data lost will be recomputed on the another executor. That is what resilience is. Now, executors behavior can be controlled programmatically. How? Configuring the number of executors and the resource available can greatly increase the performance of an application. This line, I'll just simply tell you one thing. The way you give number of mappers, the way you give number of reducers, this is the same thing. Nothing more, nothing less. Okay? That's what it is. So your executor's behavior can be controlled programmatically. Whenever you invoke a Spark context, you can tell, please go ahead and use this many mappers or this many reducers. That many mappers means that many drivers, that many executors actually. Okay. Now let's come down here. If you, are you happy with this one? Spark executors. Now RDDs. RDDs means resilient distribution data set is immutable, distributed, and resilient collection of elements that can be operated in parallel. Guys, very important. Mutable and immutable. Okay. I'll give you more explanation on this while doing practicals because theory will be quite confusing to you. Uh, Mutable and immutable is difference, but val and var. Let me write it here. Immutable and mutable means val and var. This will be touching your journey tomorrow. Don't worry about it now, but I want to explain you. RDDs are immutable, distributed, and resilient collection of elements. Okay, now one RDD is composed of one or more partitions that can be distributed across the nodes in the cluster. Guys, what is distribution? Distribution means across your cluster. One RDD is composed of partitions distributed across the nodes. I agree with you. Okay, these partitions are immutable, meaning when changes occur, new RDDs are created rather than having those changes in existing RDDs. Can you please make a note of it? This is very important interview question. Very important. When you're talking about Spark, they won't leave you without asking this question. Please. Immutable means your RDD is loading data from different nodes of your cluster. Node 1 data is one partition, node 2 data is one partition, node 3 is one partition. Like that, it has 10 nodes, it takes 10 partitions. This 10 partitions data, when it formed an RDD, okay, when a change happens on that RDD, the changed data will go into a new RDD. Okay, that new RDD will be a new Spark context from that point. Okay, that is what immutable is. Okay, these partitions are immutable, meaning when the changes occur, new RDDs are created from that point, having those changes written to the existing RDDs. Okay, please make a note. Let me know once you're done so that I can move forward. Quick. We'll take it very slowly, guys. It's very important. Okay, please make a note of it. Done?
Yeah.
Okay, very good. Now, this Spark context are they're so resilient, meaning if a RDD partition fails, it can be recreated on other node. The name itself says it's a resilient. Now, for HDFS files, the RDD partitions will be aligned with the files block to maximize parallelism and other HDP infrastructure benefits. This HDP infrastructure benefits can also be compared with Cloudera infrastructure benefits. Okay, for HDFS files, the RDD partitions will be aligned with the files block. For example, if your block is 128 MB, your partitions will be little large. If your block says 256 MB, your partition will be little more big. If your block says 512 MB, it will be little more big. Like that, your partitions are directly dependent on your HDFS block size based upon the various factors of block replication topology, and your size of the block size. Okay, now creating RDDs programmatically. Guys, till this point we have done theory. Now we are going to do practicals. So I want you to pay an extra attention, please. Now, all this while you are talking about RDD. You're talking about Spark driver. You're talking about Spark executor. You're also talking about REPLs, and you just went little ahead and understood what exactly the Spark context is. Okay. Now, after understanding Spark context, you also spend time on what happens if you run multiple Spark contexts. Now, let's create RDD programmatically. RDD means resilient distribution dataset. Okay. Now, users can programmatically create RDDs. Okay. This RDD list of number of text values using sc.parallelize API. API is nothing but application peripheral interface. Okay. Now, two things, guys. Before showing that, let me show you what I have in my exit. Okay, now Hadoop fs minus ls user Hadoop ThoughtWorks. I don't have anything here, so what I can do is I'll put some data without wasting any time. I'll put some data. Let me put some data there, guys. This grep code I'll show you tomorrow because That's very important. That will blow your mind how a small line of Spark is doing 100 lines of Java. I'm just loading one file, guys, just to show you how Spark will load. Okay. Now try to understand something. Let's come back to the PPT. This will take around 2 to 3 minutes to load. Meanwhile, we'll complete this one. Now, users can programmatically create RDDs. The very simple thing to create RDDs is sc.parallelize. That's it. Okay. Now, this is useful for learning Spark and distributing local collection of data to cluster. Okay. Now, every time when you create an RDD, you must first create a variable to assign to that. Now, RDD is my RDD and num list is the name of my RDD. For that one, I'm using SC Spark context, telling Spark, please use your Spark context now, and then parallelize. What is parallelize? Parallelize means this Spark context is creating your RDD programmatically, right? In that bit itself, internally you're telling it parallelize it. Means this 5, 7, 11, 14, please distribute this 4 values along the cluster. Okay, means this one will parallelly redistribute your RDD. Your SC means Spark context. Parallelize means it will create an RDD. While creating a RDD, it will parallelly distribute it across the nodes of the cluster. Okay, let me show you that. Spark shell. Perfect. Now have a look. I'll paste it here. Sorry, I should open PySpark, not Spark. PySpark, because that is a SpyPark context, SpyPark syntax. Sorry guys, 1 minute. Something has fallen on my screen. Okay, sorry, spelling mistake. PySpark. See here, I'll paste it. It loaded. Okay, now if I say rdd num list, observe guys, observe carefully, dot collect. See 5, 7, 11, 14. Like that, if I say that is numbers list. Now I'll say character list. So I'm instantiating an RDD, and the name of my RDD is character list spark context dot parallelize. And now what I'll say is, I'll say ThoughtWorks done. Okay, let me check the yeah, comma should be there. Thoughtworks, again Hadoop Thoughtworks, again Spark, again machine learning, again data science. Okay, you need to close the bracket and then do this bit. Now if you say rdd character list dot collect, see, now this is nothing but your rdd. This rdd is now distributed across multiple nodes in the cluster. You cannot know where it has distributed because it is not written to the disk. It is in memory processing. But when this is processed and written to disk, when this becomes an action, you will be able to see where the data has been written. This is how you programmatically define RDDs. So slowly I am moving you to writing the code, writing the programs, thinking in the programmatic point of view. Tomorrow if I show the grep code, you will stunned to see how 2 lines of Spark was doing 10 lines of Java work. Okay, now this creates RDD that contains 4 numeric values. Yes, to confirm if RDD was created and contains the correct information, we can look the content of collect. This is what it is. It's shown you like this, and here also this is text list and you did a collect. I explained you that one. Now RDDs can also take variable values as input. I agree. Okay, let me show you this one. Here guys, what he's trying to explain you is, you gave an RDD, you define an RDD, you are defining RDD. While defining RDD, you gave a name to your RDD, okay, and then said SQL parallelize. Now I'll simply say Amarnath file equal to, sorry, I'm not instantiating any Spark RDD. I'm sorry, I'm not instantiating any RDD, but just a normal name. Okay. Okay. Yeah. Sorry. Now here, if you see what I was trying to explain is, I gave Amarnath file. If I gave RDD Amarnath or correct, it didn't take it. Now see what happens. Instead of giving Amarnath file, I have to correct my statement. Give me a minute, I'll correct it. See guys, very simple. See, I didn't give any RDD. I gave directly. Okay. I did collect. It failed. Okay. Now if you see here, RDD Amarnath file, it took. Now RDD Amarnath file dot collect. How come? How come? I got it. I got it. No. Why is it failing? Did I make any mistake? Okay, sorry guys, that was my fault. I didn't parallelize it. Without parallelizing, your RDD will not be created. Okay, first example is this bit. Now this is your file. Okay, so what I was trying to explain you is here you have your data defined in this sc.parallelize, but here my data is in a file called Amarnath file. Now instead of creating an RDD directly, I'll create an RDD from the file. What is my file? My file is this one. Okay, the command must be instantiated like this. Guys, once again let me read the statement correctly so you'll understand what I'm saying. RDDs can also take variable values as input. This is the variable value. Okay, to demonstrate, we start by creating a variable named Mary file. Instead of creating Mary file, I created Amarnath file and assigning a text string value. This is a text string value. Now we use parallelize to return the variable contents into an RDD. Now I'm creating an RDD with this Amarnath file. Okay, let me show you that. RDD Amarnath equal to sc dot parallelize and then give Amarnath file. Spelling mistake, be careful. Amarnath file. Okay, this is what it is. Open bracket. Now if I say rdd amarnath dot collect, see, it has loaded. Spark sessions are the most important among all. Development leads the innovative IT world. Okay, that's what it is. Now which means your RDDs can either be instantiated or invoked directly when you create sc.parallelize, or you may have written the data in a file and you can load that file as well. Okay, now if you see here this bit, this one and this bracket around the variable name prevents the variable input from being read as one character at a time. If we had used closing brackets, the result would be different. Let me show you that. I'm taking out the square brackets and just putting circle brackets. Okay, see what happened. S as one letter, P as one letter, A as one letter, R as one letter, K as one letter, and space as one letter. Do you see the space here? Do you understand the difference between close bracket, circle brackets and square brackets? Guys, this is a circle bracket. This is a square bracket. Now, the square bracket around the variable name prevents the variable input from being read as one character at a time. It doesn't read one character at a time if you use square brackets. Okay, if you use circle brackets, every line or every input, every character is read at a time. Okay, I want you to make understand very clearly. I repeat that once again. I'll copy this one. Please make a note of it because you tend to do lot of mistakes once you create an RDD. Hope you're clear, guys. You understood, right, what I'm saying? Everyone.
Yes, Amar. Yes, Amar. It's quite clear.
Very good. Yeah. Don't do that mistakes when you write a code, because we need to write a code very carefully. Once again, I'll show it once again. Observe carefully. See, here I have a square bracket. Okay, RDD is loaded. Okay, collect. Now your whole RDD is read as one input. Okay, now if I take out the square bracket and just put circle bracket, see what happens. Every input is given as every input is read as one thing. Okay, so be careful about it. Make a note of that point in your paper or book.
It's 6 o'clock.
Make a note in your paper or book, or I can continue from there. Let me know once you're done.
Yes, we can go
Yeah,
ahead.
cool, perfect. Now let me go ahead. Another common way to create an RDD is using sc.text file. Okay, this is where I am here. Another way to create RDD is to load it from one or more text files to sc.text file. Okay, these files can be located on a local storage, SDFS, or other cloud or network storage locations. For example, you can create an RDD from a local local drive. Now, if you see here, let me show you that my thing is loaded, right? This is here. Okay, it is in user Hadoop ThoughtWorks. Now, if I want to define something, I can give like this. Okay, now RDD I load it from SDFS equal to sc.text file. Why it is text file? Because I have in text file user Hadoop ThoughtWorks, and what's the file name is deckofcards.txt. Okay, deck of cards.txt. Okay, now let me close it off. Spelling mistake of text file. F is uppercase. That's the reason. You should always remember sc.text file. Sc is Spark context. Okay, now it will work. Perfect. Now RDD SDFS dot collect. See what happens. It's collecting. See, it has defined all the values. Okay, done. Now if you say dot count, it will count number of things. It has 8,51,968 records. So we have understood how you can parallelize or create an RDD programmatically using sc.parallelize. You also understood how you can create using character strings, how you can create an RDD locally from a Hadoop file system. Okay, that's what it is. Now we understood this one also. What's our next thing we have to do now? Multiple files can also be loaded as a part of single RDD using either comma separated list of individual files. The wildcard characters are combination of two. Okay, for example, to create an RDD, two specific files. This is file 1, file 2. Okay, I can also show you that. It's very simple, guys. Load other file from here, upload, drag file, go to cards, put zipped cards.txt. Okay, it will upload for some time. After uploading, I'll show you that. Don't worry about it. Thing is very simple. You just have to give comma. This is user ThoughtWorks deck of card.txt, comma user ThoughtWorks, Hadoop ThoughtWorks, the new file name. Okay, now you can also use wildcards if you wanted to collect only few of the text files, not all the text files. You can use wildcards for that one. Happy with this one, guys? Can I move on? Everyone, do you understand it very clearly? Very important.
Yes, Amar.
Okay,
You
very
can
good.
move on.
Perfect. Now let's go to the next point, which is this one. From data files to SDFS to RDD. Guys, very important, understand something. The Spark application, Spark application that initially defines an RDD that is made up of combination of data in data files 1 and 2. Okay, let me draw a diagram here. Okay, see here, this is data file 1. Okay, sorry, this is data file 1, data file 2, data file 3. Okay, now this data file 1 is broken into 1.1. Okay, this 1.1 is broken into an RDD 1.1, 1.2, 1.3. Means, once again, I'll take a new color now. This is a big file. This big file is sitting in, this big file is here. These blocks are sitting here, block 1, block 2, block 3. Not nodes, it's block. Okay, now when your Spark is taking that file, as this block is coming from node 1, this is one partition. As this block is coming from node, this other partition. As this block is coming from others, this is 3 partitions. So for your Spark, your RDD is picked up from 3 partitions. That is one way of understanding it. And the second one is, understand the statement correctly. Spark application that initially defines an RDD that is made up of combination of data in files 1 and 2. Okay, in HDFS, these two files are represented by 3 blocks 1, 2 and 4. Okay, now take data file 2. This data file 2 is in 2.1. Okay, however there is no RDD that is made up from 2. Otherwise you will see RDD 2.1, 2.2, 2.3 like that, because this 2.1 file block may be here, maybe here, maybe here. If that is the case, you will have 2.1 here, 2.2 here, 2.3 here. Like that, the RDD of file 2 will have 3 partitions. Like that. Now let me erase all drawings, go to pointer, let me show you something interesting. Okay, I'm trying to show you something, bear with me. User, as I'm not an admin, I'm not able to see that. But if I'm an admin, if I click on this one, it will show you on which node is my replica hosted. Okay, I can see that. I'll have that information here if I'm an admin. Okay, based upon, if your deck of cards, if your replication factor is 3, it may be sitting in 3 nodes. That's a different story. But how many blocks is your deck of cards broken into, and on which nodes are the blocks located? For example, if this is broken into 4 blocks, your RDD will have 4 partitions. If this is broken into 5 blocks, your RDD will have 5 partitions. That is what the whole agenda of this diagram is. Okay, once again, try to understand something. Very careful. Processing occurs on these 3 nodes. Perfect. Now, your Spark application RDD1 is equal to data file 2 plus data file 1. Okay. Scenario 1 I explained is just understanding the partitions and blocks. Now let's understand how data will be processed. For example, your processed data RDD is this one and this one. Okay. If that is the case, it uses data file 1, data file 2, data file 3. Okay. because 1 2 and 2 guys, simple guys, you know your data, where your data, you know what your data is, but you don't know where your blocks are based. Only Hadoop can know that. It is based upon the replication topology rack awareness. Your blocks are splitted. Now Hadoop can logically go and combine those blocks. Those blocks are nothing but the blocks that are present in data file 1 and data file 2. Very good. Now this 1.1, 2.1, 2.2 creates an RDD. That RDD is nothing but 1.3, 1.1 and 1.2. This can be, here you can give 1.1, 1.2, 1.3, or here you can do 1.1, 1.2, 1.3. The name doesn't matter, but you need to understand logically how an RDD is formed from the partitions point of it. Clear everyone? Any questions on this one? Now see here, example, assume that blocks are replicated to other nodes in the cluster not shown here. Okay, to rephrase it and to make it more easy, very simple, your big file may be broken into small files. Your small files will be into blocks. For an RDD, from whichever node it is taking one block, that is one partition. Or your data file from one node is one partition for Spark. As simple as such. Nothing more to worry about it. Any questions on this one? Any questions, let me know. I'm happy to repeat it. Anyone, any questions? Is that clear?
Yeah.
Perfect. Now let's move on. Let's move on. When an RDD partitions are created in memory, focus please, understand the concept. When RDD partitions are created in memory, the nodes that will be used will be the nodes that contain the data blocks in order to improve the performance and reduce the network traffic. This line is nothing but your MapReduce process runs on the nearest local data node, just rephrased in the Spark context. Simple. Bear with me guys, I'm just putting charging. Now whenever RDD partitions are created, the nodes will be used are the nodes that actually contain the data blocks not improve the performance. Okay, this statement is nothing but your MapReduce jobs will run on the nearest local data node. Simple, there's nothing more than that. Okay, the three data blocks that represents the two files that were combined by Spark application are then copied into memory on the respective nodes and becomes a partition of RDD. I explained you very clearly. Okay, this creates, 1 minute, locally this creates one RDD. Okay, this creates other RDD, this creates another RDD. Okay, now these three blocks that are represented, okay, as two files. Agree with me everyone? Are you with me? These three
Yes,
blocks,
Amar.
these three blocks are now represented as two files. They are combined together by the Spark application and then they are copied into memory. Which memory? Their respective data nodes memory, becoming the partitions of RDD. So guys, try to understand the logic. Three data blocks representing two files. Okay, your 10 data blocks may be representing 5 files. Your 10 data blocks may be representing one file. You never know where your block is. You only know where your replication factor is. Okay, for Spark, if you go and check, if that's what I was telling you, if I'm admin, I can see this zipped cards. Where is the node 1, node 2, node 3 replication factors? I can also see the block ID, but I cannot see how the block ID are spread across. I repeat, I'll be able to see the block ID, but I will not be able to see the link of each block ID because they are programmatically sent across. Okay, so I rephrase my statement. Try to understand, very very important. These three data blocks are nothing but the data of two data files, and then they are partitioned in such a way they are loaded in the local memory, forming a resilient distribution data set. Okay, very good. You understood that point also carefully. Now, data file 2.1 is written to an RDD partition we have labeled as 1.1. Now see here, I'll show the diagram once again carefully. What is this 2.1, right? Your 2.1 is written to an RDD partition which was labeled to 1.1. Okay, you understood this one. And your 2.2 is written to an RDD partition we have labeled as 1.2. Okay, your 2.2 is labeled as 1.2. We are there, very good. And now your 1.1 is written to RDD we have labeled as 1.3. Okay, this one as this one, very good. Now in our example, if you observe carefully, one RDD was created from two files. Clear? One RDD was created from two files which split across three HDFS data nodes. You are with me? Guys, you are with me? I repeat, you have created one RDD first. Okay? That one RDD is created from two files, which is data file 1 and data file 2, but which are split across three HDFS data partitions or data blocks. Okay, now this is all loaded in a memory as a partition. Clear? If you understand this one, we can end today's class. Is it confusing, guys? Very simple. See,
Bit
yeah,
confusing, but
this is all one RDD, guys. This RDD is nothing but contents of data file 1 and data file 2. You already know your file will be broken into blocks, and that block is sitting here, and then sitting here. So your Spark is now taken three partitions. Three partitions are loaded into RDD of a memory where on this node, on this node, on this node. However, your RDD 1.3 is given name as data file 1.1. The contents of 2.1 are given as 1.1. The contents of 2.2 are given as 1.2. That's it. That's it. There's nothing more you need to understand here. Don't break your head. If you need to break your head, I'll let you know in advance. Don't worry about it now. That's all you have to understand. How two files are broken into blocks. How RDD1 is combined data of two blocks and combined data of two files, and how it is reading the contents of these files from the blocks splitted across the nodes. That's all it is. Don't break your head now. So simple, so easy. I don't want you to confuse more than this one. Enough. Okay, don't worry about it now. Now, coming to the next point. If you see here, this is the start. This is the continuation to that one. Now, the hypothetical cluster has two RDDs. Each RDD is a multiple partitions which is distributed across cluster. We know it. Okay. Now, RDDs can contain any type of serializable elements, meaning that can be converted to any of the byte stream. Somebody was asking me, show us how we convert the data, how you convert unstructured data to structured data. So this means your RDD can be text file, can be converted to paraquat file. Your paraquat file can be converted to text file. Your sequence file can be converted to Avro file. Your Avro file can be converted to text file, like that. Now example. This includes int, float, boolean, and sequence iterative like arrays, lists, tuples, and strings. Elements, okay. Elements in RDD can be mixed as well. For example, an array or list can contain both string and int values. Furthermore, RDD types can be converted implicitly whenever possible, meaning there's no need to explicitly specify the data types. Guys, see, understand something here. I'll show you in my diagram. I was preparing some notes for you guys. Not this one. is not ready yet. I thought I made it, but it's not ready yet. I will cover that tomorrow. How this data types works and how you see in Spark. It's very simple. You need not have to do any variable initialization. If you just give 1 2 3 4, it takes as an int. If you say Amarnath, or if you say Hadoop.works, it says this guy has given me letters. So let me interpret and go and start working. That's how it works. Okay. So I don't want to bombard you now. We are happy till this point. Okay. This diagram, don't worry about it. You will get to know it practically. I'll show it on Cloudera cluster because I have full admin permission on Cloudera cluster. I'll show it on that. Don't worry about it. Okay. So that's all I have for today. If you have any questions, let me know. Just a quick recap. We understood how we programmatically write RDD. We understood the Spark driver. We understood the Spark executor. We understood why Spark conf is important. What happens if you don't initialize Spark conf, and what happens if you initialize Spark conf again once it is all loaded already. Okay, these are the things. Any questions? Let me know before I sign off. Very important. We are getting there. You have understood the concepts now. You need to understand what is transformations, what is actions, and we can jump into practicals.
Yeah, I think so far so good, Amar.
Okay. Any questions, feel free to let me know. You can ping me on WhatsApp. Okay. Thanks, guys. Have a great day. Enjoy your work. I'll see you tomorrow.
Okay, all right, Amar.